The era of hiring expensive developers to manage your backend is over. If you are still manually updating databases or sending emails, you don't have an app, you have a chore. In Module 4, we are bridging your app to the cloud using digital tripwires. While others are stuck on manual code, we are building a secure pathway for your AI to run your business 24/7 without you lifting a finger. I've distilled weeks of complex Google Cloud architecture into this few minutes masterclass. Stick around because I'm revealing the God Mode SDK that gives your AI supervised control over your app's data and the one setting that stops hackers from draining your cloud budget. Let's get to it. Module 4. Extending functionality with Cloud Functions. Introduction to Serverless Computing. What is serverless computing? So, serverless computing is an execution model where the cloud provider manages the server, allowing developers to write and deploy code without worrying about infrastructure. The core principle is that your application's logic is executed in a stateless environment that scales on demand. The model offers significant benefits, including automatic scaling to handle traffic spikes, a pay-as-you-go pricing model where you only pay for the execution time of your functions, and the elimination of server maintenance. The Cloud Functions environment. Firebase Cloud Function is a service that runs your backend code in response to events triggered by Firebase features and HTTP requests. Each function runs in an isolated, secure container and is managed by Google. These functions can scale automatically from 0 to thousands of instances based on demand. The environment is flexible, supporting runtimes like Node.js and Python, allowing you to use a language and ecosystem you are already familiar with. When to use a function. Cloud functions are ideal for use cases that require server-side logic but don't need a dedicated server. This includes tasks such as background processing, for example, sending a welcome email when a user signs up, integrating with third-party APIs, or performing complex data processing that is too resource-intensive or insecure to run on a client device. Any logic that needs to be triggered by an event or that needs to run in a trusted environment is a perfect candidate for a cloud function. Triggering functions from Firebase events. Firestore triggers. Firestore triggers are a powerful way to execute server-side code in response to data changes. You can attach a function to a specific document or an entire collection and listen for 4 types of events. On create, when a new document is created. On update, when an existing document is modified. On delete, when a document is removed. And on write, which combines all 3 events. This allows you to perform tasks like validating data, sending notifications, or updating other documents whenever a data change occurs. Authentication triggers. Authentication triggers enables you to run code in response to user life cycle events. The 2 primary events are a new user sign up, that is on create, and a user deleting their account on delete. These triggers are useful for tasks like creating a corresponding user document in Firestore for new signups or cleaning up all users' data from your database when they delete their account. Storage triggers. Storage triggers let you run functions whenever an object is uploaded, archived, or deleted in cloud storage. The most common use case is running a function when a new image is uploaded. The function can then process the image, perhaps by creating a resized thumbnail or analyzing its content, before saving the result back to storage or Firestore. Real-time database and analytics triggers. Cloud Functions also support triggers for the legacy Firebase real-time database, which works similarly to Firestore triggers but on the older JSON tree structure. Additionally, you can trigger functions in response to user behavior logged by Firebase Analytics. This is useful for processing user data to create customized app experience or to perform data analysis. HTTP functions for custom API endpoints. Creating a RESTful API. An HTTP function is a cloud function that can be invoked via a standard web request. This allows you to create your own custom API endpoints without managing a server. You can use these endpoints to handle complex client requests like processing payments or perform any other task that is directly tied to a Firebase event. Handling HTTP requests. When an HTTP function is called, it receives a request object that contains all the information about the incoming request. This includes the HTTP method, that is, get, post, put, and more. The request body for post requests, and a query parameter for get requests. Your function's logic will use this information to determine what action to take. Here are some common HTTP request methods. Get. Get requests data from a specified source. It's used for retrieving information and shouldn't be used for actions that change data, as it is meant to be idempotent. That is, making multiple identical requests has the same effect as a single request. And save. It doesn't alter the state of the server. For example, asking for a menu at a restaurant. You get information, but you don't change anything. So that is how the get request method functions. Post. This sends data to a server to create or update a resource. The data is included in the body of the request. For example, submitting an order form at a restaurant. You are creating a new order. Put. This replaces all current representations of the target resource with the uploaded content. It's used to update an existing resource or create one if it doesn't exist, like get. It is also idempotent. For example, replacing an entire dish with a new one. Delete. This removes a specified resource. For example, canceling an order. The head. It retrieves only the headers of a resource without the body. It is useful for checking what a GET request will return without having to download the full content. For example, looking at the title of a book without reading the contents. Patch. This applies partial modifications to a resource, unlike put, which replaces the entire resource. Patch only updates a specific part of it. For example, asking for extra cheese on your pizza. You are modifying a part of your order, not replacing it entirely. These methods are fundamental to how clients like a web browser and servers communicate on the web, forming the basis of the REST or representational state transfer architectural style of designing networked applications. Managing the response. After processing a request, your function must send an HTTP response back to the client. The response includes a status code, for example, 200 for success, 404 for not found. Optional response headers and a response body that can contain JSON data or plain text. You have full control over the response, allowing you to build any kind of API. Securing HTTP functions. HTTP functions are publicly accessible by default. To secure them, you need to implement an authentication mechanism. A common pattern is to use Firebase Authentication ID tokens. The client sends its token in the request header, and your function uses the Firebase Admin SDK to verify the token and ensure the user is who they claim to be before executing the main logic. Integrating with other Google Cloud services. The Firebase Admin SDK. Within a cloud function, you can use the Firebase Admin SDK to interact with Firebase services with administrative privileges. This means your function can read and write to any document in Firestore, manage user accounts, send push notifications, and access other services without being limited by your app's client-side security rules. The Google Cloud Client Library. Cloud functions are part of the larger Google Cloud ecosystem. To interact with other Google Cloud services that are not part of Firebase, you can use the respective Google Cloud Client libraries. For example, you could use a library for the Cloud Vision API to analyze images uploaded to storage, or the Cloud Translation API to translate text from a document in Firestore. Service accounts and permissions. Every cloud function runs under a special service account. This account determines what your function is allowed to do. You must grant the necessary permissions to the service account in the Google Cloud Console to allow your function to access other services securely. This separation of duties ensures that a function can only perform the tasks it needs to do, minimizing security risks. Advanced Cloud Functions and Security. Environment configuration. You should never hardcode secrets like API keys or password in your function source code. Instead, you should store them as environment variables. Cloud Functions provide a secure way to manage these variables. When your function is executed, the environment variables are available, allowing it to access third-party services without exposing sensitive information. Organizing functions. For simple projects, a single file may be sufficient. However, as your project grows, organizing your functions becomes essential. You can structure your code into multiple files, and you can organize your functions by topic or service. This makes your code base more maintainable and easier to debug. Error handling and logging. Robust error handling is crucial for any production application. You should wrap your function's logic in try-catch blocks to gracefully handle unexpected errors. Cloud Functions automatically send standard output from console logs to Google Cloud Logging. This centralized log provides a way to monitor functions execution and debug issues in a production environment. Cold starts and optimization. A cold start is the time it takes for a function to spin up from a dormant state. This can add a few seconds of latency to a request. To mitigate this, you can optimize your function by using simple dependencies, loading resources at the global scope, and generally keeping your functions lightweight. The goal is to reduce the function startup time as much as possible. Deployment, monitoring, and maintenance. The deployment workflow. The primary way to deploy Cloud Functions is by using the Firebase command line interface or Firebase CLI. The CLI packages your code, uploads it to Google Cloud, and provisions the necessary resources. You can deploy a single function or all of them at once. For production apps, it's a best practice to deploy one function at a time to minimize the risk of introducing a breaking change. Function monitoring. After deployment, you can monitor your function's performance and health in the Firebase and Google Cloud consoles. You can view the number of invocations, execution time, error rates, and resource usage. This information is vital for debugging performance issues, tracking costs, and ensuring your functions are running as expected. Maintenance and updates. To update a function, you simply make changes to the source code and run the deployment command again. Firebase will automatically update the function in the cloud. You should also periodically update your function's dependency to patch security vulnerabilities and fix bugs. When a function is no longer needed, you can delete it using the Firebase command line interface to avoid unnecessary costs. After having a detailed understanding on the vital role of Cloud Functions on our apps, in the next video, we will have a hands-on approach building a live app that demonstrates the concepts we just uncovered. We'll be building a My Plants Doctor app which has AI agentic features like plant image recognition and diagnosis with surprisingly amazing results. With Firebase authentication backend enabled, you can sign up, upload a plant image from your device photo library, take a quick snapshot with your device camera, choose file from device storage or Google Drive. Amazing, right? Do check out this full course playlist, Vibe Coding with Google Firebase, a complete no-code to advanced AI application development course. Remember to support our efforts with a like, subscribe, and I'll see you in the next video. Cheers!